If you're enjoying Pigoted Podcast, then why not sign up to our Patreon? You can find it at patreon.com/Pigoted, and on there you get loads of extra benefits, such as early access to episodes. You get access to Pigoted Extra, which is extra content from our guests, usually about 45 minutes to an hour long of extra content every single week. You get merchandise, you get to ask questions, you get to be part of our Discord community. We have a Discord server where people chat and ask questions and discuss topics that have been brought up on the podcast. You get all that through Patreon, and it starts from just £3 a month. Plus, you'll be supporting the podcast. You'll be helping the podcast to grow, helping us to fund bigger and better guests and to pay for all the editing and that kind of thing. So please, if you are enjoying Pigoted, then think about signing up and becoming a Patreon from just £3 a month over at patreon.com/Pigoted. Welcome to Pigoted Podcast. Joining us today is comedian Dean Coughlin. Hi, Dean.
Hello.
And joining us as our expert is Ben. Hi, Ben.
Hello.
What are you, Ben? What are you an expert in for those of us that haven't listened to the Flat Earth episode?
I am an astrophysicist.
Yes! And what is it that we are going to be talking about today?
We're going to be talking about black holes.
You excited?
Black holes, bro, yeah? Let's get in it. Jump in.
So let's get started. What is it that you know about black holes, Dean Coughlin?
Not that much, to be honest. In what way? Like how?
In the way of knowledge.
I mean, I don't really know much about them at all, other than that, like, no one knows what happens when you go through one.
Well, I thought this as well. So
people know.
I have two things that I know about black holes, and I'm more prepared for both of them to be wrong. So the way that they are is it's just loads of, it's like a spot where gravity is so strong that nothing can escape from it, not even light, which is why they're black holes, because light can't escape. The light goes in and can't come out, so it looks black. But also, I believe that we don't know loads. Like there's a lot of stuff that we don't know about black holes, purely because they're a right fucker to observe.
Yeah.
Because obviously you can't get too close to them, otherwise you'll get sucked in.
I mean, that is a problem, yes.
And no one knows what happens when you're inside of one. So you just... I don't know what this podcast... Imagine if it's him going to be going... Imagine if Ben just goes, yeah, we don't know a lot.
There's loads we don't know. Right, I know this is going to sound dead stupid, but like, is there not like a real scientific way you could like sort of fishing rod something into one? Like, obviously you'd have to do it more technical than fishing rodding it in. But you get what I mean, though? Like,
fucking idiot.
No, but like,
talking about.
I know it sounds stupid.
So
I need obviously a more technical fishing rod.
It's a hole. So it's a hole where the gravity is so strong that not even light can escape.
Yeah, but you're not trying to escape, though, are you?
Of light.
You're not trying to escape. You want to go in and see what's happening.
Yeah, but the fishing rod.
It does all the work itself. It sucks it in for you. Like, can you not just throw a camera on like a really, really long piece of really strong rope?
Have you tried that yet, guys? Have you?
Bet you haven't.
Have you tried strong fishing wire?
Bet you haven't.
No.
Told you. That'll work. That I reckon that's a $1 billion idea. It'd have to be a proper legit setup. Like, you couldn't just fish off the side of the.
I love the idea
space
of
station.
well, that's it. I love the idea of like an astronaut looking like a garden gnome, just collecting evidence.
Yeah.
I put a lot of thought into what I might get asked on this podcast, and can you fish in a black hole was not on my list.
Let me send you the text message that he sent me because it fucking cracked me the fuck up, right? So I asked him whether or not, just checking that he was all right to pick him up, right? And Ben said, sounds good to me. I'm just writing up some black hole notes. And I said... 4 laughing emojis, which is how seriously I took that comment. I put, I can't wait. Don't worry if it's not too in-depth. Our minds will be blown anyway, right?
I've blown his really.
And he put 1 laughing emoji and then put, Mostly just making sure I can answer a question about something like Hawking radiation or the information paradox without resorting to a basically nonsensical string of words like quantum 0-point energy in curved time-space, since I feel like we probably don't have enough time to unpack all that. Having a human understandable explanation ready to go is probably a good plan, I feel. And we've opened with, can you not just use a fishing rod?
Can you not, though?
Okay, so first off, wow, I sound like an absolute dickhead in that sentence, don't I?
No, I loved it.
Second off, no, you can't fish in a black hole.
No? Oh, well.
So,
Never mind. Scrap that one then.
Scrap that idea.
Yeah.
all right, so the fundamental principle of a black hole is like for any two bodies, there's a gravitational force between them. And if you want to, like if you're, say, on the surface of a planet and you want to get away from the planet, there's a minimum speed you have to reach before you can do that. So from the surface of the Earth, it's 11 kilometers per second. So that's what rockets do, is they get you to that speed so you can leave the Earth's gravity.
That's why they have those boosters on rockets, isn't it? So the rocket goes up and the boosters get you to that speed and then they go fuck off like that and they go.
Yeah, so the ejecting boosters is a way to kind of keep the rocket weight down because the rocket has to lift itself and also all of the fuel it's carrying.
I see, right.
And the more weight you can get rid of as you go, the more efficient you can rocket. So
how do they? Sorry, this is a complete tangent, but I imagine those boosters weigh a fucking ton. How do they not do it so it doesn't land on someone's house or something like that?
So they plan the launches so that they fall into the ocean.
Really? Fuck.
Fucked if you're just having like a nice little yacht ride, a fucking booster lands on your head. I weren't expecting that one.
Oh, fucking hell.
So the strength of gravity depends on two things: the mass of the object and how close you are to its center of mass. So if you get closer to the center of mass of something, you get a stronger gravitational force. Now, ordinarily what happens is you hit like the physical surface of the object first. And if you go into an object, it doesn't work the same way because you start having like, if you go down in an elevator shaft towards the center of the Earth, some of the mass of the Earth is above you and pulls you in the opposite direction. So your weight actually decreases until you end up being weightless in the middle. But
Yeah, because you can't come out the other side if you're being pulled back into the middle, can you?
Sorry, that in itself is just fucking baffling. So you'd be weightless in the middle of the Earth?
Yep.
You're constantly, you're like free fall, wouldn't you? Kind of.
Yep.
In the middle.
If all the weight is distributed equally around you, it's pulling you in every single direction at once, and all the forces cancel out. So you're just...
Oh, right, okay.
Would you float or would you just be like pulled apart?
You'd float.
I thought you just sort of collapse into yourself. I thought you
would have just been like pulled off in all different directions, like...
I mean, this assumes that you've created like a cavity in the middle of the Earth that you can float in.
Yeah, you'd just burn otherwise, wouldn't you?
Actually full of is like radioactive iron.
Right,
So
okay.
probably don't go and have a swim.
So put that to one side. Black holes.
So black hole is an object where you've taken all of this mass and squashed it down so that you can get much, much closer to the center of mass before you hit the surface, which means the closer you get, the higher your escape velocity becomes until you reach the speed of light as your escape velocity. And the speed of light is the ultimate speed limit of the universe. Nothing can exceed that, which means it's called the Schwarzschild radius, the kind of theoretical.
Oh, now
distance.
you've said it. The Schwarz, yeah.
I thought that was a hair dye.
Oh, fucking hell.
There is another name that you might know,
Go on.
which is, so the Schwarzschild radius is the distance from the center of mass to the surface at which the escape velocity is the speed of light.
Okay.
The surface that describes is called the event horizon.
I've heard of that.
I've not heard of that.
I've heard of that, yeah.
I'm fucking
Couldn't
lost.
tell if you had have asked me like what is it, I wouldn't have been able to tell you, but I've heard that name of something.
I'm fucking lost already, mate. I'm absolutely lost. So because like so we never experience the gravitational forces of being in the center of the Earth or whatever, because obviously there's the fucking ground that stops it.
Correct.
When a black hole, there isn't that ground, and so you experience the maximum gravitational forces of everything that the black hole is a lot more.
Absolutely,
And
yeah.
so it gets to the point where you have to get to the speed of light to get out of it, and that's the fastest thing in the universe, and nothing can get faster than that, and so nothing can get out of it. So, first of all, do black holes have mass then?
Yes.
So how do we know that?
So, okay, there's two different ways to answer that question.
Don't worry, I won't understand either of them.
So yeah, you want.
Just pick one.
Unless you
Just
say
pick either.
I asked about fishing into one, so it really doesn't matter what you say.
Yeah, the first way that we measure mass is we see how many fish are in.
Pick the simpler one, probably.
He thought a black hole was like a koi carp.
Yeah. Like ice fishing. I thought you could just do something like that. You'd have to be better than a fishing rod, but I think.
Oh god! Right. Okay. Go on.
Right, just to finish off why fishing into a black hole doesn't work.
It's
If
never
you
been
cross
tried.
the event horizon,
That's just.
Go on.
information from the other side of the event horizon cannot reach us.
Right.
There is just no physical way there's no route from inside the event horizon to outside. So anything that crosses it no longer exists meaningfully in our universe.
Ugh.
Right. Fucking hell.
Say theoretically, right? Let's just say the fishing rod idea was like, this is how you done it. And you had like a camera with a feed back to whatever you were on that was far enough away from the black hole that you didn't get sucked in. Could like the data through a cable not escape it because of is that because of its density, or is it, that's weird that it would affect data?
Internet connection.
Yeah.
So
The Wi-Fi in a black hole.
Yeah, no signal there.
So it gets weirder
Right.
because one side effect of very strong gravity is that time slows down when you are subjected to it. So this is a measurable effect.
Wait. Time slows down in strong gravity.
Yep.
How?
So this is a little bit of general relativity for you.
Right. Okay.
So gravity curves space-time around it.
You knew that.
Gravity. It's just those words. Gravity curves space-time around it.
Yeah.
Right. Okay.
So this is
But I didn't think that. Sorry. Again, I didn't think that gravity was a physical thing that could be curved around. What's space-time curving around? If gravity is just like a force and nothing, then what's it curving around?
it is curving around the fourth spatial dimension, kind of.
Why is it every time I ask something, the explanation makes it even harder to understand?
Okay, right. So picture it. So the way to picture this is the kind of the rubber sheet example. So if you've got a rubber sheet stretched out with space underneath it, and you put something heavy on the rubber sheet, it bends.
Yeah.
downwards.
All right, I'm with you.
Okay, so that's the curvature of space-time, is
Okay.
that bending. And the reason that things move differently under the influence of gravity is they follow straight paths on the curved space-time.
Okay.
So if you think of one of those like machines that you put a coin into and it just goes round and round and round and round, eventually down, the coin is trying to follow a straight path along the surface, but the surface curves, so the coin ends up going around in a circle.
Oh, dude, that's fucking right. Okay, so does that mean, therefore, that if we could get to the elevator shaft into the middle of the Earth, then time would move at a different pace?
Yep.
Fucking hell.
So
Is it how relative is it though? So is it like seconds, or is it like you go down to the middle of the Earth or whatever, and you spend like an afternoon there just chilling in weightlessness, and then you go back up, and then your missus would be 80 or whatever, and you'd be like, oh shit.
okay, so it's nothing like that strong.
Okay.
So the good example for this actually being proven is GPS satellites, because the way that GPS works is you've got a bunch of satellites in orbit, and they put out a signal that basically just tells you the time, and your phone or whatever receives them, and it goes, okay, I've got a signal from that satellite that says 10 seconds ago, and from that satellite that says 5 seconds ago, which means I know how far those signals have traveled because they travel at the speed of light. So I know what the positions of those two satellites is.
Wait, so that's how your phone puts the time on your phone?
That's how your phone works out your location on Earth.
Jesus Lord.
Crazy, innit?
It's fucking unbelievable. Do you know what, right, it's someone's job to do that, and I can barely understand it.
Yeah.
Do you know what I mean?
Yeah.
Like, it's fucking mental.
And you get fuming when like you can't get it on your phone. Like, fuck, this phone's shit. And it's like, do you not understand what's actually needing to happen for you to just know where you are?
So when
Like, you can't get mad at that, can you?
So when I'm using my phone as a sat nav, which I do all the time, traveling to gigs and stuff, my phone is speaking to probably dozens of satellites.
That's the sat, innit?
In the air.
In SatNav.
Yeah, but
Satellite
your phone-
navigation.
Your phone doesn't need to communicate back. It just needs to receive those signals.
Okay.
So it goes, okay, I've got like...
Fucking hell.
It makes it well cooler, though, doesn't it, when you're driving
Does.
around knowing that you're being guided by satellites?
Oh, mate, that trip to Hull's going to have a whole new meaning.
Yeah, exactly.
So here's the really good bit. In order for GPS to be accurate, the phone has to compensate for the difference in the rate that time flows between you on the surface of the Earth and the satellites in orbit.
Oh,
What's the difference in time between them?
Fractions of a second.
Right,
It's
okay.
tiny.
but still, though, fucking
Yeah,
hell.
it's still mad, isn't it? Yeah. Wow.
Do you know what I mean? That's crazy. So do we know how much slower time moves in a black hole?
So here's where stuff gets weird.
Right, okay.
I-
If it
I
hasn't
say,
already.
like, yeah. So because black holes are so insanely dense and so ridiculously gravitationally powerful,
Yeah.
all of these effects get dialed up to 11. So the event horizon is the point at which the time experienced by an object falling into the black hole stops.
Wait. So it never truly falls in?
It never truly falls in.
Where does it go?
So once you hit the event horizon, your mass is now a part of the black hole system.
Right.
And because of the way that gravitational force works, like I mentioned center of mass a moment ago, all the mass acts through the center of mass of the object, you now contribute to the mass of the black hole. So the event horizon grows a little bit.
So it's not really a black hole, is it? So it's not, because when you think about a hole, the whole thing with a hole is that you fall into it and then you come out the other side
Yeah.
somewhere. And that's what I thought sort of black holes were.
When really it's
That you
just
pop-
sticking to something. 'Cause
Yeah,
You
like-
can't get off it.
Yeah, it's more like a black tar, isn't it?
Yeah. Yeah.
It's more like a giant tar pit in the sky.
Yeah, that's a better way of looking at them.
But rather than
But is it a like a spherical object?
It is a spherical object. So this is one of the few things that is really easily defined about black holes is like they are a spherical region of space that you can never leave.
get that flat earther back on, he'll fucking tell you otherwise.
I mean, the picture of the black hole does look flat, though, to be honest.
Is that the one with the accretion disk around?
Yeah.
So this is really interesting as well. So any material falling onto a black hole, obviously, like you start out somewhere very distant and you kind of get dragged towards it by its gravity.
Yeah.
But you're not going to be heading like pinpoint accuracy into the core. You're going to have some little bit of other velocity, like you were already traveling or...
Yeah.
Right.
So sort of the way like Saturn's got its rings type thing. It'd have
Yeah, so
some
it's
stuff.
conservation of angular momentum. So you don't fall directly onto the black hole, you fall like a little bit past it.
so like in its
I know what you're
orbit
saying.
type thing. Right. Okay.
So how are you tracking all this perfectly?
I've read some of Neil deGrasse Tyson's book.
Didn't realise you'd done homework.
It got hard though.
Mate, this is fucking baffling to me. I don't think I even... Right, okay, so I get the point that it's more like a big fucking blob of tar that you don't fall into and come out the other side somewhere. There is no other side. It's just
I mean, there might be. Is
because light can't escape from it, you don't actually know what you're looking at, do you?
Is that why we went about fishing into a black hole? Is that why you couldn't fish into it then on a basic sense? Is that if you fished into a fucking tar pit, you throw your fucking rod out and it'd just go on the top. It wouldn't
Yeah.
go into anything.
Wouldn't go into anything,
because there's
yeah.
nothing for it to go in because it's too dense.
So that's why it's a stupid idea.
Yeah.
Not because it's not a hole. It's because it wouldn't work.
No.
I see. No, it's all right, Freddie.
I think what I was going for is that it was stupid in more than one way. It was stupid in a way that you didn't even realise.
Yeah, no, yeah.
Okay.
Okay, so the whole like time dilation thing. I mean, have you seen Interstellar?
Yes.
That's a great-
So I was going to use Interstellar as a point of reference. So they go up to. See, the thing is I get Interstellar confused with another film as well, and so
I haven't seen Interstellar.
Interstellar one. So they go to a planet on Interstellar where it moves. Time moves quicker relative to time on Earth, doesn't it?
Yes. So
In fact, here's a little fact for you that you might not even know. So on the planet, there's like a ticking sound on the planet. It's almost like a metronome sound, isn't it?
Yep.
That sound happens every 1.25 seconds, which is also the exact amount of time that a day would have passed on Earth. You knew that, didn't you?
I did, yes.
Of course.
Rick! I thought for a minute that I had something that he
Did you
didn't know.
not? Did you not hear the information he reeled off about Buffy before we started? He clearly knew about the metronome.
That's true. Before this, we were talking about Buffy the Vampire Slayer, and he literally, it was like listening to IMDb,
Yeah,
wasn't it?
yeah.
He knew literally everybody.
It's insane.
Yeah, all right, fair enough. I love the idea that he'd come away from this and being like, I didn't know
learned
the
something.
tick. Yeah. And our heads would be a fucking mess
Yeah.
on the floor, but he'd be like, the tick thing was interesting.
yeah.
And I'd go, yes, it was. We all learned. We all equally learned an equal amount. Right.
I'm so sorry.
Is Interstellar also the one where they communicate with the aliens and they send a linguist up there who makes shapes?
That's Arrival.
Those are the two that I get it confused with.
Okay, so Interstellar kind of illustrates the whole, if you get close to a black hole, like your personal clock slows down.
Okay.
So time on Earth passes a lot faster than time on planet black hole or whatever you want to call it.
Yeah.
It's completely wrong about the whole, if you fall into a black hole, you get to end up behind your child's bookcase and communicate to them with the ticking second of a watch.
Spoiler alert!
Oh yeah, I was going to watch that. So when you say like it affects your age, so like you won't age as fast,
Correct.
so it has effects on your cells.
Yes.
Yeah, anti-aging moisturizer is little bits of black hole.
Yeah,
Except you don't get to, you kind of don't get to experience your newfound immortality because your experience of time slows down in the same way.
right.
So as far as you're aware, like everything about you is completely normal. You're aging at the same rate. You're walking around experiencing days. But the rest of the universe, if you were able to observe it, that's sped up.
Right. Okay.
But also, right, so if you were to be in the mass of a black hole, and I think that's a better way of saying it other than fall into a black hole, innit? So if you were to be into the mass of a black hole, time would slow down to such a degree that it would be observable if you could observe it. However, your time is slowing down, but your perception of time is not.
Yes.
So even though time will be moving at a fraction of a second, your brain doesn't slow along with that time.
Like you've got a watch on your wrist and the watch just keeps ticking
Yeah.
completely regularly. But what happens is the rest of the lifetime of the universe passes in what feels to you like a single second.
Jesus fucking Lord. Right, okay.
So would your watch tick at the same speed? Like,
From your point of view, yes.
yeah, right. Okay.
Because it's science words, it's in your inertial frame of reference.
Okay.
So the same things that are affecting you are affecting your watch.
Right.
Okay. So my question would be that, like with black holes, I imagine that they change in size, don't they?
They do.
So I imagine they get bigger the more shit that gets put into them.
Absolutely correct, yes.
Okay. And so why aren't they just going to get bigger and bigger and bigger and engulf everything?
So The simple answer to that is because the universe is expanding.
Okay, so the universe is expanding quicker than they're sucking shit in.
Yeah.
Have
Right.
two ever stuck together?
Black hole mergers. There are 4 different types of black hole.
Okay.
There are the stellar mass black holes, which are formed when a star of a really heavy star dies.
Okay, so that's when they're like collapsing on themselves
Yeah.
and form a black hole.
Yes.
How long does that take? Does that take like done in the blink of an eye, or does it take like a millennia?
So the process of, the star has run out of fuel and collapse begins.
Yeah.
Fractions of a second.
Wow.
The core just implodes in
Is there
on
a
itself.
video of that anywhere?
No, because that's, not one that's like an actual observation. I'm sure there are like,
Fucking cool.
Like CGI ones.
It'd be cool as fuck to watch that, wouldn't it?
although we can see this happen, kind of, because what happens to the rest of the star around the core is called a supernova.
Okay. So it's sort of like the wreckage from the accident.
Effectively, yeah.
Okay, so like when you see like a car accident on the motorway,
Yeah.
you see bits of fucking debris and a wing mirror,
The accident was that fast.
and Dave with his
Yeah.
fucking legs in the fucking
Yeah.
Astra and his torso in the tree.
That's a Vauxhall Nova.
Oh, mate. I mean, come on, take that. Let's
Yeah.
let's just take a minute to appreciate
I had
that.
to redeem myself from the fishing line.
That's a fucking excellent joke. That's the bit that I'm going to be clipping up and putting on TikTok. I'll give you that much. What an excellent bit. Well done. I knew there was a reason we had you on.
It's all right.
Right. Okay. So supernova, you can see that's the wreckage.
Yeah. So supernova, the outer layers of the star lag a little bit behind the core collapse.
Okay.
So they fall inwards and then they kind of bounce.
Yep.
They hit the surface, huge spike in density, huge spike in heat. You get, nuclear synthesis of all the elements heavier than iron.
Okay.
All of the gold, for example, formed in a supernova. There's nowhere else in the universe that you can form it.
Yeah.
Wait.
I was going to ask you about this.
All the
something I
gold
wanted-
has been formed in a supernova.
Was gold and silver two neutron stars colliding, and then that's how it got to Earth?
So,
What the fuck are you
No.
two talking about?
No.
okay, so history of elements in the universe.
Right.
So the universe starts and it's all energy. And, the most famous equation in all of physics, E equals mc squared,
Yep.
says that you can convert energy
Energy
to matter.
equals mass c squared.
C being the speed of light.
Yeah, of course.
So energy can spontaneously turn into mass. Specifically, it turns into subatomic particles, like the most simple building blocks of matter.
Wait. So, fuck. So energy can spontaneously turn into mass.
Yep.
So you can just sort of like be minding your own business,
Yeah.
and then all of a sudden there can be like a blancmange in front of you, possibly.
Yes, possibly.
It's your dream, not it? Just hopefully one day there's just a bunch in front of
if
me.
If that happened, you'd be like, honestly, like imagine explaining it to somebody and being like, listen, I'm just watching telly.
This is what I think paranormal activity stuff is. Like genuinely, do you know when people go, oh, like something fell off my shelf, like the picture flew off the wall?
Yeah.
Is it not possible that shifting particles have just like changed
I mean, it's
the
possible.
atmosphere around an object and knocked it off?
Oh yeah, I live in this house where we keep getting blancmanges on the coffee
house.
table. It's either E equals MC squared or a ghost that's on Bake Off.
You never know.
So in terms of like big scale stuff like that, you don't really expect that to happen because it's the statistics against it are.
But it's technically possible.
It is technically possible.
Okay.
What happens a lot more easily is you get hydrogen.
So is it equals MC squared the Big Bang then? Because there was nothing, no mass, but loads of energy, and then if you have an infinite amount of time of nothing, well, I mean, time isn't relative, is it? Because it's not even, there's nothing to measure time in or against. There's just nothing, and then there is something because
Not really. So E equals mc squared is more of a property of our universe.
So it didn't exist before the universe.
It might not have existed before.
Oh, dear God.
The Big Bang has a lot in common with a black hole in that our current laws of physics kind of break down when you get too close to it.
Right, okay.
So we've got a bunch of models for how stuff works, which is what science is essentially. And all of those models are to some degree wrong.
Oh, I know little bits about this, or at least I think I know little bits about this.
We'll see.
So can I jump in here and just sort of explain?
Go on.
Don't worry, Dean. I've got this.
Yeah. I want to hear from a real expert here.
So, right. So I know, or at least I think I know,
Right.
that that like our current model of the universe kind of falls apart when you factor gravity into it.
Yeah. So this is
there's bosons. Oh, he looked at me like a proud father then, didn't he? There's bosons.
say
and
the words, you can do it.
something beginning with T. Theons. Therons.
His face has changed.
Thenons. What's the opposite? What's the other one of bosons?
Leptons?
No, maybe.
I mean,
Who knows?
Probably that one, isn't
He
it?
probably knows it.
He's probably going for this.
Probably knows it. Yeah. So our current model of the universe and all this fucking shit, it falls apart when gravity is entered into it.
Right.
So that's what string theory is, isn't it? It's like an attempt to remodel the universe in a way that accounts for gravity.
Okay.
I'm not sure where I'm going with this. What?
It's a really good example. So
Yeah.
Really good try.
Yeah, good effort. Do you know what he's doing right now? My explanation was a child drawing that he's just put on the fridge. That's why.
Yeah, I'll tell you how it
Do you
really
know
is,
what?
though.
I'm really pleased. It does look like an explanation.
Yeah.
Well done, Freddie. Look, we'll bring your missus over. Look what Freddie's done with his words. Look at that. Well, what a good lad. Oh, you're so clever. That's it, isn't it? Yeah. Okay.
I'm going to pretend I wasn't about to make a joke about putting it on the fridge there, and we're just gonna move on. So, right, all scientific theories are like you base them on observations, you come up with a model that works, and they work to describe things like the observation.
Right.
So you start with, say, Newton's model of how gravity works.
Right.
Now, Newton's model of how gravity works is really, really good.
Yep.
It works brilliantly if you want to do things on like a human scale.
Yeah, if you sit under a tree, then an apple might fall on your head.
Yep, and you can calculate really precisely how hard that apple will hit you.
Yeah, okay.
But if you scale up a little bit and you look at the precession of the orbit of, say, Neptune,
Yeah.
Newton's theories are off by a tiny little bit.
Okay.
And if you scale up even further and start looking at like things on the scale of galaxies, they start to be off by a lot.
Yeah.
Because
So is this the general theory of relativity?
the general theory of relativity is what's
Fucking yes.
Lovely stuff.
Knocking about in his head.
Lovely stuff, that.
Thank you, mate.
So general relativity kind of takes Newton's laws, adds in the little bit that was missing, and now we can do like galaxy scale stuff and going up sort of universe scale stuff. And at the very other end of the scale, you've got quantum mechanics. And quantum mechanics is like the tiniest building blocks of reality. How do these things work?
Is that what I was talking about with string theory? Yeah.
Yeah.
So-
Of course.
So in my head, I mean, I seem to remember, and I'm pulling bits of fucking knowledge from like in my head right now, there is a little man rifling through like a filing cabinet, and he's going like that, and he's looking for string theory.
Yeah.
And but the file on string theory is like there's a bit of paper here, and there's something under there, and there's like half a banana that someone squashed in there, and it's all fucked up. But in my head, the way that someone told me, or the way that I've been taught at some point to think about string theory is it's like you give all it's like you stretch these bosons or whatever out like a string, and you give them vibrations in which to sort of move off, but then you close it round. So it's more like a circle that moves at different rates and frequencies. And oh, mate, I feel, honestly, I feel so, when an expert looks at me and doesn't say you're full of shit, I get such a little tingly feeling in my tummy. It's hunger, that is. Blancmange! No.
Maybe.
Yeah, so string theory is like an extension to quantum mechanics, because quantum mechanics is like, okay, within this little realm of scales dealing with the smallest possible stuff, we can really accurately predict everything they do.
Until the split theory, double split theory, you won't be able to tell what they do then, do they?
So this is
is that something different?
I can't remember the name for it. Where you've got two slits in a piece of card and you shine a light at it.
Yeah.
Quantum mechanics predicts the outcome of the slit experiment really accurately.
But okay. But when you observe it, it changes, doesn't it?
Yes, this is the kind of the act of observing changes the thing that is observed.
Oh, the Heidegger principle.
Yes.
Yeah.
Or more precisely, the Heisenberg uncertainty principle.
What?
Heisenberg uncertainty principle.
Oh, did I get it wrong?
I mean, you were close.
Really?
He said to things that you've got wrong, I think.
He's just been polite.
Yeah, he's just trying to be nice. You're in his WhatsApp groups and we go, you can't believe some of the shit these are saying.
Nothing in the world can ever be accurately observed because the act of observation always changes it.
Yeah.
But
that happens down to like particles, though, doesn't it?
Yeah, so that's...
I always think about that when I think about like Big Brother and stuff like that. You know, like when you like have like those reality TV shows where it's just a load of morons in a house and they've got the cameras on them. You always think they would act totally differently if those cameras weren't there. But would they act differently if the cameras were there but they weren't on?
They didn't know.
Yeah.
I always feel like, do you know what, like videos you see on Fail Army and that?
Yeah.
Like, was the act of going, I'm going to film this, like the knock-on effect
catalyst
to them falling off?
Yeah.
I always think that about stuff like them types of videos and that.
I think sometimes
it being observed, innit?
Sometimes it defo is with like, I think as well with like fight videos and stuff. I think the minute that the amount of times I'm watching like a fight video on the internet and it's two people who clearly quite don't want to fight each other. Yeah. And then a crowd of 20 people will get their phones out and they're like,
Yeah.
Well, if I get my head kicked in, it's not going to be as bad as looking like a pussy. So I'm just going to have to go ahead.
Just see what happens.
Just see what happens with this. What were we talking about? Black holes.
Yeah, black holes and limits of theory. Okay, so quantum mechanics works really, really well until you scale it up to the point where you'd have to think about gravity, and then it starts to break down a little bit. And general relativity works really, really well until you scale it down to the point where you'd have to start to think about quantum mechanics, and then it breaks down a little bit. So there's this interface between the two that we haven't quite got figured out yet. And black holes are kind of similar, because once you get close to a black hole, or indeed to the singularity at the Big Bang, the models we have aren't quite good enough yet.
Okay.
Now we can get back to sort of tiny, tiny fractions of a second after the Big Bang.
Yeah.
And know really well what's happening at that point.
But it's the bits right at the end.
The bit right at the edge. It's like the very outer limit of human understanding.
It's like when you're chopping an onion. Like, I'm really good at chopping an onion. Where's this going? I don't even know myself. I'm really good at chopping an onion and I can get it perfectly. But those last little bits are just a fucking nightmare. And I always think I'm going to slip because my grip isn't good enough on the edge of the onion. And then I always end up with about 98% of the onion chopped really well, and then a stubby little fucking bit.
So that stubby little fucking bit is the bit science can't work out yet, isn't it?
Yep. Yeah. And the act of doing science is the act of like going and getting a magnifying glass and a scalpel so you can do the last little bit.
Yeah.
Building the tools to let you actually get there.
Do you have your own like theory on what happened before the Big Bang, or?
Honestly, I'm not even sure that the phrase before the Big Bang exists.
Right.
Like, time is part of space, and space didn't exist before the Big Bang, so time might not have done either.
So there was just a nothingness.
But when you say a nothingness, though,
it's not
surely that
comprehend.
nothingness has to be a part of something.
But the way I always thought of it from a philosophical point of view, which is where I thrive more than the actual, I thrive more on bullshit where I can explain my way out of it a lot better than science, is if you have nothing for an eternity, it becomes statistically certain that there will be something.
As long as the existence of something is a possibility.
Yeah.
So that's kind of the...
But if you leave it for an infinite, but we can't even comprehend what nothing is.
Yeah.
Do you know what it is as well, right? This is going to go off on a tangent.
Oh, really?
But yeah. I mean, who'd have thought? But human beings are phenomenally bad. I always think about this when we think about like talking about space and stuff.
Yeah.
Human beings are phenomenally bad at processing big numbers. Like it gets to the point where once we get past about 1,000, we just have no fucking, like, we have no idea what that looks like, that number.
Yeah.
And I've always thought it's because evolutionarily we never needed to know what that number looked like. So we know from a distance, if I asked you to name how many people are in a distance and you had a choice between 3, 5, 10
or
and
4 billion
and 16.
Yeah.
No, but if you just had those numbers, you get it right 100% of the time. Because we're just really good at, because that's the numbers that we deal with. There's 3 predators, or there's 5 fucking prey, or there's 10 people coming to attack us, or whatever. And those are the calculations that we need to make. But when it comes to like billions of things, we just have no actual concept. And I'll give you a fact that will illustrate how we just don't understand numbers. So think about a standard deck of playing cards. I bet you already know where this is going.
I don't, actually.
Why, he's gonna fucking learn something.
I'm along for the ride.
If you shuffle...
Unless you get to the end of the point and he goes, nah, it's not really that way.
Oh, mate. I hate it when that happens.
We'll see.
So if you get a standard deck of playing cards and you shuffle them, you are arranging them in a sequence that has likely never before existed and never will exist again in the history of the universe, because the amount of different combinations is fucking to the power of 50, however many there is in a playing card. And that number is so vast that, like I say, you're arranging those cards in a way that will have never existed before in the universe and probably never exist again. But the number itself, the number of different combinations of orders of playing cards in a pack of cards, that number is so big that if you put that number on a big countdown clock and pressed countdown and it started ticking down, and every billion years you took one step forward until and then you waited another billion years, took another step forward, another billion years, took another step forward. If you did that until you went around the entire the entire Earth, then you put a sheet of paper on the floor, and then you did the same thing again, a billion years per step going around the Earth, and then put another sheet of paper on the floor. If you did that, if you did that until the papers reached the moon or the sun, and then and then you did it again, and for every time you walked around the Earth, you took a piece of paper off until the stack went back down again. And then you took a drop of water out of the ocean and then did it again and again until the ocean was dry, and then filled the ocean back up again, you still wouldn't have hit a third of what that number is.
That's a really convoluted list of things you need to do. Your
Well,
weekends must be wild.
That's big, that, isn't it? Massive, that.
I think the actual one that I got mixed up midway through that, but the actual thing is you put a piece of paper down and then you take a drop out of the ocean. And then once the ocean's dry,
so it's not that
put
big
another. It's even bigger. You put another piece of paper down, and then you fill the ocean up again, and then you put another piece of paper down, and then that's how big that number is. You wouldn't have even done a third.
That's stupid, that.
And
that's just playing cards.
That's just a pack of playing cards.
But
like, again, it just goes to show that we cannot possibly comprehend the size and scale of the things that we're talking about.
Yeah, like when you go, the sun's like however many million miles away you go.
93 million.
How far's that?
Taking that. Do you know who taught me
88
that?
minutes.
Joe.
Fucking Joe the Flat Earther.
Yeah, see, you learning.
Yeah,
Learn
and
something.
also there's a scene in The Office, the American version of The Office, where Andy knows loads of facts about the
right.
sun for some reason. So it was rattling around in there as well.
Oh, nice.
93 million miles away. Anyway, black holes. So how do they start, black holes?
Okay, so there's a few different ways, but the main one is a dying star. So a star...
Oh, you said there were 4 before, didn't you? And then we
Yes.
went sidetracked. So dying star was 1.
Dying star is one. So stars exist in what's called a hydrostatic equilibrium between gravity, which is trying to crush everything in, and the radiation pressure generated by their fusion, which is trying to push everything out.
We also didn't get back to gold and silver.
Shit, no, we didn't.
We're going to tie up all these loose ends.
I'll keep that one in my head.
Okay, we'll do
Okay.
that one next. Yeah, so fusion happening in the heart of the star, that's trying to push everything outwards. Gravity is trying to push everything inwards.
Right.
And those two forces balance for the entirety of the star's life until it can't do fusion anymore, which means it's run out of whatever fuel it's using, usually hydrogen, bit of helium, bit of lithium. When that happens, gravity takes over, tries to crush the star. And there are 3 potential outcomes.
Yeah.
So something about the mass of our sun, what happens is the core collapses into basically solid matter.
Yeah.
So the stuff that we're made of, and that's supported by, so you've got your atoms with electrons on the outside,
Yeah.
and the electrons can't occupy the same space as a neighboring electron. So all the atoms kind of banged up against each other, and that's what supports solid matter.
Right.
That's a thing called a white dwarf. So the star will just radiate what's left of its heat.
A Warwick Davis.
I was going to say, I think you have to call them white little people now. What a day.
Option number
You laugh every time at that now. If someone says white dwarf, you'll go, Warwick Davis.
It's the same letters as well.
It's the same what?
It's the same letters.
Oh, yeah.
WD, yeah.
Imagine if the matter condensed in on itself and formed the exact outline of Warwick Davis. Like, it just formed a little Warwick Davis in the sky. And we all had to, like...
We knew.
It's an observable thing.
The incredible.
Okay, so option
Option
number
number
2.
two.
Please don't tell me there's a black dwarf option, because I think that's going to get me cancelled.
No, well, option number 2.
Red Dwarf? Is that a thing?
That's a TV show.
Okay. I'll just be quiet.
Don't go through all the colours either. Like the blue dwarf.
Smurf?
Yeah.
Option number 2, for a star that's sort of 10 to 20 times the mass of our sun,
Okay.
the atoms jostling up against each other isn't enough to counteract the gravity.
Okay.
So the electrons get forced into the core of the atom that they orbit, combine with protons and form neutrons,
Okay.
and you get a star mass object made only out of neutrons, which is called a neutron star.
Right.
Still not a black hole.
Still not a black hole.
Option number 3, stars that are 20 or more times the mass of our sun.
See, even that's hard to fathom, isn't it?
Yeah,
Just
yeah.
20 times bigger than the
Yeah.
sun. You go,
If you said to me, what is 20 times bigger than that telly?
yeah,
I'd have honestly no fucking idea. Maybe that window behind us.
yeah.
Maybe.
No.
You reckon?
IMAX. I go IMAX.
No, it can't be an IMAX.
20 times bigger than that.
I reckon that window, again,
Yeah.
watch it on the internet. I reckon that window is 20 of those TVs.
I can't see the window, so
Well,
I don't know.
like a 4x4 grid of those TVs would be 16. So it's a 4x5 grid. So yeah, window's probably about 20.
Yeah.
Nice.
Nailed it.
Yeah.
I'm so happy. I'm so smart. So
So 20
third-
times the mass of the sun.
so we've got a Warwick Davis.
Yeah.
A white dwarf, yes.
We've got a what was the second? A neutron.
Neutron
A Jimmy
star.
Neutron.
Yeah.
Yep.
Right.
Option number 3, 20 times or more the mass of our sun. Even the force trying to hold the neutrons apart can't win over the gravity, collapses down to a point. That's your black hole.
Okay. Black hole.
Because it's just the core of the star, those tend to be they end up about 5 to 10 times the mass of our sun,
Okay.
but concentrated into a single point.
Okay.
That's your black hole. Those are your kind of stellar mass black holes.
Okay.
Above them are your intermediate mass black holes, which are kind of a few hundred times the mass of a star.
Okay.
Those are formed by stellar mass black holes merging with each other. So you mentioned this earlier, like, do black holes ever merge? Yes, they do. And we've detected the gravitational waves that are produced when that happens.
Jesus Lord wept. So the black hole thing, you know, again, not really a black hole, just a big black sticky blob of tar that shit gets stuck on and can never leave. Mm-hmm. What about the other two that you mentioned, the white dwarf and the neutron star? What do they have interesting properties and shit?
Yeah, so white dwarfs are pretty much the most boring stellar object because there's no kind of active process happening. They're just radiating heat.
Do they? Is the gravitational pull at such a level that time will change on them?
Yes, because they are like masses comparable to the sun, but really quite dense. So I mean, if you go close to the sun, you're experiencing very strong gravitation, like a lot stronger than the Earth.
Yeah.
So you're getting that time dilation effect.
But it's not as strong as a black hole because the black hole doesn't have that surface. So I'm fucking learning, aren't I?
Yeah.
Shit's getting pieced together. It's like me learning something is like a very slow jigsaw.
Yeah.
Do you know what I mean? Where and right now I think I've got a corner piece.
Yeah, you found the corner piece.
I think it's a 1,000-piece jigsaw.
Not sure which corner yet. I found one and I'll know at least.
Right, okay.
So yeah, one of the cool things about white dwarfs is you can, under certain circumstances, end up with a white dwarf that's actually a 15-kilometer wide diamond.
Really?
But, you know, good luck harvesting that and not crashing the global diamond market.
Okay. Well, the global diamond market is a fucking sham, innit?
Run by the De Beers Corporation.
Yeah, so De Beers, do you know this?
No.
So De Beers got everyone... So diamonds, right, are plentiful as fuck. They're fucking everywhere, right? And De Beers, who were the company that they got everyone together and they said, all right, listen, diamond farmers, so it's in our best interests to vastly limit the global supply. Yeah, diamond farmers. That's what I went with.
Miners, aren't they?
What?
The miners, aren't they?
No, farmers. Farmers, what you do is you plant a small diamond and then that makes a diamond tree.
Oh.
And then you come and you just pick. That's it. But at the moment... because of Brexit, a lot of there's a lot of immigrant labour that is going short at the moment. So a lot of diamonds are just falling into fields, and no one's bothering to pick them up. Still, blue passports. Anyway, diamonds are plentiful, but they vastly limit the supply of diamonds so that they can still charge fucking dick tons of money. And also, so do you know how much money you're meant to spend on an engagement ring?
They say it's something stupid like 3 months salary.
That's literally De Beers who made that up.
Yeah.
So also the phrase "diamonds are forever" to try and prevent you from trying to resell your diamonds.
Yeah, diamonds are a girl's best friend as well.
Yeah, they just made all that up.
Shirley Bassey, they made her up. So that's the thing about diamonds. There's fucking loads of them.
That's snide, that, isn't it?
A lot of them are used as well, as is my knowledge. A lot of them are used not for jewelry and stuff, but a lot of them are put into machining stuff because they're very, very sharp.
Like the hard, aren't they?
Yeah, and so they can cut stuff. So 90% of diamonds just go to machines and shit.
I did not know that.
There you go. Yeah. You've learned something. I'm fucking well happy. Yeah. Andy's learned the card thing as well.
Yeah. Wow.
2 things you've learned, and I've only learned 1 thing about black holes. Up your fucking game.
Only because you can't understand it. I spent an hour with a scientist that didn't learn anything. Because he can't comprehend anything that he's saying.
He's not strictly at fault, to be fair. It's sort of like trying to teach It's sort of like trying to teach magic tricks to a dog, isn't it? Like, and then the dog turned around and going, "You're shit, you." Right, okay. Right, so white dwarves, Warwick Davises, they're not particularly...
dense as well. Apparently so bad.
Do you know what? There is a... this is... Fuck it, I'm going to say it. So there's a comedian who has dwarfism and is white, and picking her up is dense as fuck. It's genuinely, she is heavy. She is bloody heavy, and you wouldn't think so, because you just look and you go, that'll be all right, but it's compacted in, and deceptively
like a
heavy.
white dwarf, dense, aren't they? White dwarfs.
Yep, they are quite dense.
Yep.
Not as dense as neutron stars.
Nope.
Neutron stars far, far more dense. Like a teaspoonful of neutron star material weighs as much as a planet.
What?
Isn't that the same with like dark matter? Or is that even is that more dense?
So dark matter doesn't get to those densities. It's, again, going into kind of a cosmology line here, but the particles that make up dark matter, because they can only interact gravitationally, they can't lose energy the same way that normal matter can. So they keep a lot of their speed after the Big Bang. They kind of get slowed down by the expansion of space.
Right, stop there. Repeat what he just said.
They get slowed down by the expansion of space.
No, that's the last thing he said.
You feel like a dog.
Dark matter can't cool down after the Big Bang, so it can't gravitationally collapse to those densities. There we go.
Yeah.
Because in my head, I was like, I don't have a fucking clue what he's saying.
It's heavy. It's heavy.
It's heavy as fuck, lad. I got to think about neutron stars. If you had a teaspoonful of that would weigh as much as a planet.
Yep.
And then you said other words, and for some reason my brain just went, you don't need this. So you were saying it into my ears, and my ears were just pushing those words out of my fucking thing.
Okay, so
Forgotten the word head now as well.
I'm having a dump.
I'm going to leave here stupid that I came in. And I started this by saying we can fish into a black hole. So, just so you know.
Oh, fucking hell. Right, okay, say it again, and I'm going to stay with you for as long as I can.
What, the bit about the dark matter?
Yes.
Okay, so dark matter gets produced the same way as all other matter at the beginning of the universe, but it only, like, all other matter can interact with kind of electromagnetic forces, it can radiate heat, it can kind of collide and undergo sort of nuclear forces. Dark matter just does gravity. And what that means is that there's no mechanism by which dark matter can get rid of its initial energy.
This is the bit that I'm losing.
There we go.
This is the bit.
So as space expands...
Talking about how does normal matter get rid of its initial energy?
So it can radiate it away.
Okay.
In the same way as, like, if you heat something up and it glows.
So that's the thermodynamic law of something.
Yeah.
The law of thermodynamics.
Yes.
Okay. So
that's one option. You can also, like, those particles can collide and exchange energy.
Excess. So yeah. So when things collide with each other, there's a transference of energy, isn't there? And heat energy and other shit like that. But dark matter can only interact with gravity.
Correct.
And gravity being a force doesn't transfer heat or shit like that.
They can transfer energy, but it's much, much less efficient. So when you're forming a galaxy, you start with, like, big sphere of dark matter and also normal matter. But the normal matter can kind of collide and radiate and lose energy and sink down towards the middle and form a galaxy. The dark matter can't do that. It just stays on its crazy random orbits.
And that's how they make the chocolate. No idea,
Anyway,
though.
getting back to neutron stars.
Yep.
So neutron stars are really interesting because one thing you can get with a neutron star is a thing called a pulsar.
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 Right.
So what a pulsar is a neutron star with a very strong magnetic field. And what that ends up doing is channeling charged particles into two beams.
Right. Okay. So, right. Okay.
So charged particles moving around the star get forced to the kind of rotational poles and spat out in these two huge beams of, like, really high energy radiation.
Okay. Like lightsabers.
Like lightsabers, yeah.
Okay. Cool.
Yeah, like lightsabers.
I just have to picture it in
It's
my
more
head.
like Darth Maul's lightsaber though. There's one from each side. So
I just have to picture something in my fucking head.
Just
that when he's talking about
you can go right
pulsating.
lightsaber.
Yeah, so in my head now, I'm picturing a planet with 2 fuck off lightsabers.
Yeah.
Yep, good picture.
Okay.
So with a pulsar,
I'm helping you as well. So don't you look at me like I'm bringing the class down.
My thing is, I don't even know if what he's saying is true. So I'm like, yeah, you might be telling me all these real things, but I don't know if you've got anything wrong in there with someone else listening. I go, actually, you missed out a little bit there.
Yeah.
I'm just like, yeah.
But we won't even be able to understand what it is that he might have possibly.
That's what I mean. Yeah.
Our level of understanding, it's just baffling. Do all your friends talk like this?
What's your WhatsApp group like?
Like you or like me?
No, like you. Because I don't imagine that you would hang around with like me and Dean on like a regular basis, because we wouldn't be able to just... Because this is a slog, innit?
You having a nice chat about Buffy before? I don't know what you're on about.
We did, but even then he was operating at a higher level.
Yeah, he was, yeah.
He was.
What's your WhatsApp groups like? Have you got a WhatsApp group?
We do have a couple of WhatsApp
Do you
groups,
send each other like science memes and that?
No.
Yeah, absolutely they do.
He could show you a meme that you won't understand.
Right,
That's
so here's the thing. In your WhatsApp groups, do you ever send each other pictures of that massive black guy with that huge big black dick? Okay, the fact that you don't even know what that is is proof that we operate on different fucking levels.
Very different levels.
Because there was honestly, during lockdown, there was maybe a month-long period where every picture message you'd receive would be this black guy with the biggest dick you've ever seen in your entire life.
I don't think I've ever received that message.
That's it. Yeah. They operate on different levels. Do you ever wonder what it would be like to like have some sort of brain injury and like just have an average IQ or level of like understanding?
I mean, I do now.
Because you must hang around with other people who are dead clever as well. You must do, because it must be exhausting for you to like converse with us. It must be exhausting.
It is not exhausting. It's really good fun.
Just a lot.
Oh, bless him.
It's going over the foundations for him. He's just like relearning the basics, just going over. It's like it's a nice little refresher course for you, isn't it?
An abnormally high proportion of people in my friend group have physics degrees.
Yeah, that would make sense, wouldn't it?
Yeah, I feel like I want to hang out with the dumbest one of your smart friends. That'd be the easiest night out, I think.
I'm not going to nominate somebody as the dumbest one of my friends.
But you know who it is.
Instantly knows who it is. He instantly knows who it is. Yeah. He does in his head. He's like, Derek, that's who it fucking is.
Yeah, man.
Anyway, pulsars.
So just to recap where we're at the moment, Warwick Davises, Jimmy Neutrons, and then lightsaber pulsars.
Yeah.
Which is a type of Jimmy Neutron.
Which is a type of Jimmy Neutron with exceptionally dense mass.
Yeah.
So in a pulsar, the two beams twist around the star so they're not aligned with its rotation. And what you get then is that the beams are being spun around like a lighthouse beam, shooting off into space.
So they're like giant... They're like... It's like a gobstopper surrounded by an electrical field.
Pretty much, yep.
I get you.
You get that one?
Yeah, nice one for that one.
Do you know what I'm quite good at, right? Is, and I'm just going to toot my own horn here. I am quite good at taking whatever fucking nonsense he's saying and distilling it into a really obvious analogy that everyone can see. I think I'm quite good at that.
Yeah.
I mean, I still myself don't have a fucking clue.
No, I don't know what it is.
Oh no, I don't
picture it in my head.
Gobstoppers in space flying around.
Yeah.
And giant sticky black balls of tar that are black holes and shit.
Yeah. And Warwick Davis.
Fucking hell, gobstoppers and tenables. Look at that.
So if you're in the path of the beam, you see it as it passes by as a really bright flash.
Okay.
Of radio waves, usually.
Okay.
So we detected this. Very, very good astronomer by the name of Jocelyn Bell Burnell.
Oh, J. Bell Burnell?
Yep.
No idea.
She
Jay Bell Burnell.
I know, yeah. Sounds like a Black Betty, doesn't it?
I just took Jocelyn and I just put it to Jay,
like
and I
do.
just did it with a little bit of confidence, and that was enough to sell him.
I couldn't even remember.
Jay Bell Burnell. You see, they might be smart as fuck, but they're gullible as well.
It's the information's like so not going in. I couldn't even remember. But what is it? Bell Burnell.
Jocelyn Bell Burnell.
Bell Burnell. I couldn't even remember that bit. I was like, who's that? Who are we talking about here?
She's a really good astronomer.
Oh, okay.
Oh, she's fucking great. What Jocelyn Bell Burnell did is she measured the pulsar waves emitted and the electromagnetic frequency that came off the pulsar neutron star.
Yes, exactly.
Fuck off!
I mean, I'm not sure what electromagnetic frequency means, but...
Mate, I don't know what any of it means.
Just saying words there.
Did I get close?
Jocelyn Bell Burnell detected the first pulsar.
Oh, mate, I fucking blanked the shit out of that.
Yeah, but if you hadn't mentioned that name right at the start and went, what did she do? You would have went, don't know.
Okay.
It's only because we were talking about pulsars.
So you're taking my victory away from me.
That one, yeah.
I predicted what he was going to say, and you couldn't remember the name of the thing that I was predicting.
Yeah, I know, yeah. That's fine, though.
What was her name?
Jay Bell Burnell.
Yes! Yes, mate.
Even then, I was questioning myself. I was like,
that is what I'm going to be calling her from now on.
What's her first name?
I don't know. It's gone now.
Have a guess.
So it sounds a bit like...
It's if you budge past someone.
What?
If you
Jostle?
You budge, yeah.
Jostle. It's not Joyce.
No. Don't let him have it. Don't let him have it. He's close.
All I can think of is Joss Stone. No.
It's Joss Stone Bell Burnell. Joss Stone Bell Burnell. And do you know what happened? When she first detected a pulsar, someone said, another physician said, "Is that really right?" And she went, "I got a right to be wrong." And that's how the song came about.
Oh, okay.
So what's her first...
Also, physicist and physician, slightly different things.
Yeah. Anyway, don't take this away from me. What was her first name? You're so close. So when you barge past someone...
I don't know what that word is.
You said it before.
Jostle.
Yeah?
Jocelyn.
Yes!
Okay. I didn't know.
Just very quickly.
I didn't know jostling was bumping into someone.
So, just very quickly, let's take what Dean's just said. I didn't know jostling was bumping into someone, and let's reread the text this afternoon. Mostly just making sure I can answer a question about something like Hawking radiation or the information paradox without resorting to a basically nonsensical string of words like quantum zero-point energy and curved space-time. I didn't know jostling was bumping into someone. I told you were doing too much. Because my exact fucking message was, ha, you vastly overestimate my knowledge.
Yeah.
And I really wish you'd have taken more of that to heart.
I mean, this is a proven thing. Like, people who know a lot about a field will vastly overestimate how much other people know.
Yeah.
Even when deliberately trying to compensate for that.
Yep. And the other end of that is the Dunning-Kruger effect.
It is indeed.
What's
Which,
that?
do you know about the Dunning-Kruger effect?
Don't think
So the Dunning-Kruger effect is the more incompetent somebody is, the more they have a false sense of confidence in their own abilities.
Okay.
So their incompetence actually prohibits them from being able to see that they have made mistakes and have accurate self-reflective.
Okay.
So, for example, if you think about a doctor that's misdiagnosing their patients, and you have GP here, patient there, and the patient says, "I've got a sore arm," and the doctor goes, "It's cancer, that, mate."
Yeah.
And you go, "Fuck, that sounds bad." And she goes, "Yeah, off you go." And then the next person comes in. How does that doctor then know that they've misdiagnosed that patient?
The first one?
Yeah.
I didn't know there was a question coming at the end of that, to be honest.
So you weren't listening?
Well, yeah, I was listening, but I wasn't trying to work.
There would be a test.
Yeah, I wasn't trying to work anything out.
The point is anyway. The point is that your own incompetence inhibits you from getting better, and it's almost ironic in a way that you have to have a certain level of skill in order to improve at something.
So it's like just like being delusional on something. So like when you see like some comedians,
Yeah, so there are some stand-ups that are so phenomenally bad at comedy.
and you're like, how do you not know how bad you're doing there? Type thing.
And they're so bad that they will go on stage and not understand how bad. So when I first started, I remember doing
You
a
go,
gig.
come on, this is funny. This.
I
Like,
remember doing a gig when I first started. It was maybe a year into comedy. So when you're a year in, you do open spots, you do 10 minutes, and usually you're on with another open spot if it's a professional show or something like that. And I was doing one of my first professional gigs, was very nervous, and I was on with another open spot. And I went on and had probably the best gig that I'd had to date. And I was like, wow, I came off and I thought, wow, I really feel like I'm doing all right with this.
Yeah.
And then the other open spot came on and died a really solid death. And maybe the only laughs that they got were from people in the audience going, ha, 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 like that.
Yeah.
But they came off and go, oh, I can't believe we both smashed it. And I had to go, yeah, it was a great gig, wasn't it? Go, yeah,
Because
brilliant.
And because you don't have that sense of, I done bad there, what can I change to get better?
In my
you
head,
stay at that bad level.
Well, in my head, I remember thinking, if I'd have had the gig that you'd had, I'd come off stage and I'd be absolutely gutted.
Yeah.
And that to me was like, okay, well, I'm not suffering with Dunning-Kruger then.
Yeah, right, okay.
Do you know what I mean? But yeah, it's a weird little psychological
Yeah.
coinky-dink.
Yeah. Scientific term, that as well, isn't it?
Yeah, coinky-dink.
Coinky-dink.
That's actually the fifth type of star.
Yeah, a coinky-dink.
A coinky-dink.
There's a scientific term I did want to bring up,
Okay.
which is spaghettification.
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 You'll remember this one.
And with that is the most convoluted fat joke of all. I actually really like pasta as well.
Oh, good. So do I.
Do you?
Yeah.
What's your favourite type of pasta?
Probably fusilli.
Oh, nice. Okay.
I've not really thought about what my favourite type of pasta is up until now. It's all just
Why do you like fusilli?
I don't know, because a little spiral. It's kind of cute.
See, now we talk about pasta.
Yeah.
I sound like him and he sounds like me.
Yeah.
Do you know what I mean? Because
You're,
I'm like,
you're talking about like sauce distribution and all
yeah,
that
exactly.
with the pasta, and it's
Well,
just
I was
like-
talking
just like the
about I was
shape.
talking about how rigatoni
Yeah.
is very good for like keeping sauce, retention.
Yeah.
And he's going, it's just in a nice shape.
It's nice, lovely.
And it's amazing how when it comes to food, it's completely flipped 180, and now I'm the fucking expert.
Yeah. But it's
Like,
like,
no, well done.
Thank you.
Well done for that.
With that going on the fridge.
Fusilli is in a little twist. And you've done a really good, honestly.
And penne's on with the tube, right?
Yeah,
And you
small
put a
tube.
pea down the
Small
tube.
tube. Rigatoni is bigger. And do you know what conchiglie is?
Haven't the foggiest.
Italian for shell. That's how you know. It's the shell pasta. You're welcome.
Thank you.
You're welcome. Tagliatelle, that's slightly fatter.
Yep.
Yeah. Pappardelle, which is even
I
fatter
don't
than
know
that.
that one. No.
It's even fatter.
So there's like subtle gradations of
Fatness.
of pasta.
Yeah. And then linguine, which is like really small, skinnier than spaghetti.
Fascinating. Next time I go shopping, I will.
You're
actually,
very welcome, mate. You're very
I will look at
welcome.
the pasta aisle and I will know. I will be informed.
You're very
able to
welcome,
choose the
mate.
appropriate pasta.
You're very welcome. I'm really pleased. That's 3 things. That's 3 things he's learned.
yeah.
3 things. Nothing.
He's going to leave here going, fucking trying to tell me about linguine. I already know that shit.
Right, so spaghettification
Spaghettification.
is where you... In fact, you give me the beginning and me and Dean will just sort the
work it
rest.
out, yeah.
We'll sort the rest.
Yeah.
Okay, so what's an appropriate beginning?
Well, this doesn't bode well, does it, Dean?
No.
I have mentioned that the strength of gravitational force increases as you get closer to the center of mass of something,
Yes.
which means that if you're standing on the surface of the Earth, the strength of gravitational force on your feet is slightly stronger than the strength of gravitational force on your head,
Okay.
because your head is slightly further away from the center.
Okay.
Can I just come in dead quick? Is it true that if everyone crouched into a little ball, the Earth would spin a little bit faster?
Yes, that is conservation of angular momentum.
That one. Yeah. I knew that was there somewhere.
That's not actually spaghettification, that's gnocchi.
Oh, yeah.
Very clever joke for me there.
Pasta-based humour. This is it's not what I was ready for.
Oh no, mate. Well,
You never know where it's going to go.
So on the surface of the Earth, you can't feel that difference because the difference that your height makes compared to the distance you are from the center of the Earth is tiny.
yes.
But if you're falling towards a black hole,
Yeah.
your height can be a much larger proportion of that distance. So you get a much bigger difference in force.
Did you get stretched into spaghetti?
You get stretched into spaghetti.
Really?
Yeah, man.
I was miles away from that.
I went for literal.
Yeah, well,
spaghettification or whatever. it's
when he
called.
started at the feet thing, I thought maybe your feet go to spaghetti, and then I was like, that's stupid.
Well, your
And then
10 toes would sort of.
Well,
at first,
I
wouldn't
started
it?
thinking, actually, more literally, sorry, less literally, and I started thinking about how when you cook spaghetti, you get a pan of boiling water,
Yeah.
and naturally the bottom half of the spaghetti,
Just come back to food.
the bottom half of the spaghetti has to cook and soften before you can fit it all
Right, okay,
into
yeah.
the pan.
Yeah.
And so I assume that there might be a state where half of your body was rigid, like the
top
uncooked
of the
pasta,
spaghetti.
and then the bottom half was bendy. That's where I was going for in my head.
Ironically, the subject of spaghetti has such strong gravitational force that Freddy cannot escape it.
Yeah. Oh, mate. I'm going to go and make a bolognese tonight. I don't give a fuck.
Starving them.
Yeah, right. Okay. So you would get stretched into spaghetti.
You would get stretched into, well, you would initially get stretched into a line 1 atom thick, and then those atoms would themselves be torn apart as you fell into the black hole.
But then you wouldn't fall into anything. You just layer on the top, wouldn't you?
Yes, you would pass the event horizon and
Is it a
Cease to
giant
exist.
meatball? That's what I want to know. It's essentially a giant meatball with spaghetti stuck to it. That's all I've learned from today. I'm going to go home and spend 2 hours with an astrophysicist there. What have you learned? Black holes, big meatballs.
Do you know what? There is something in the fact that we've spent, again, nearly 2 hours in the company of an astrophysicist and learned so little.
Oh.
Like a bafflingly small
Absolutely
amount.
nothing. I've genuinely learned more about pasta. Because I know the words that you're using for that.
What was the name of the
tests again.
astronomer that discovered was it pulsar?
Jocelyn.
Barbara.
Is it Barbara Ann?
No. No, right, okay.
I'm not stupid.
Okay.
Can I just say that?
Jocelyn, and then think about the end of your dick.
Bell.
Yep.
Bell. I'm trying to think of how I had it in my head before because it was like Black Betty. Belberin. Something like Belberin.
Oh, he's so close. He's so close.
Put me out of my misery. What is it?
Jocelyn.
I'd like to apologise to Dame Jocelyn Bell Burnell.
Oh, she's a dame.
Yeah.
Sus.
Soz.
that
Yeah,
mean?
like she's going to be offended about this.
Yeah, she watches this, I think.
I love how as well I said the end of your dick and you went Bell straight
yeah,
away. It was
thank-
like,
Oh, I'm a scientist.
it's Jocelyn Foreskin Burnell. That's my name. Okay. What sort of different, like when a star collapses in on itself because it's run out of fuel,
Yeah.
what are the options other than black hole?
Neutron. White dwarf.
See, he's fucking learned shit.
Yeah. That's it, isn't it? Or black hole. There was
Yeah,
a
black
fourth
hole's
one.
one, and then the fourth one's 2 black holes, isn't it?
Oh, right, yeah.
Combine.
So each core collapse will produce only one black hole, but
Okay.
you can get black holes interacting and merging later on.
Fucking Lord above.
Mm.
It's been a heavy one, this, hasn't it?
I've enjoyed it.
It's been good. Well, we are going to we're going to have a break for us to just sort of fucking decompress a little bit,
Yeah.
and we are going to go back and record Pigoted Extra, where we are going to talk about the origins of the universe a bit more.
Yeah. And we'll get back to that gold
We will.
thing
Oh!
on there.
Do you want to do the gold now, Dad,
Go
quickly?
All right, so really quickly, the simplest thing for energy to turn into is hydrogen. So the early universe is made pretty much entirely of hydrogen.
Yeah.
Hydrogen can be fused together to make helium and release energy, which is what powers our sun.
This is periodic table, isn't
It's a
it?
periodic table.
Hydrogen's number 1,
Yep.
and then helium.
then lithium.
And lithium
So
batteries.
this is what stars do in the early part of their life, is they fuse heavier and heavier elements to make energy to balance out their gravity. And that stops with iron. So iron is the heaviest element that can be produced through fusion, because past iron, you would absorb more energy than you produce by fusing them. So past iron, you can do fission, which is splitting them apart to release energy,
Fishing.
Told you.
which is where we get our nuclear power from. We take uranium, which is a very heavy element, and split it into lighter elements.
Yeah.
But in order to produce those heavier elements in the first place, there's only one process in our universe that does that, and that is a supernova.
Right.
So everything on the periodic table heavier than iron, so anything to the right or down,
Yeah.
is produced in supernovae,
Okay.
and that includes gold. So all the gold on our planet
Isn't from our planet.
isn't from our planet. It's produced, well, it's from our planet in that it was there when our planet formed.
Yeah.
It's kind of wrapped up in it, but
But it's
wasn't.
come from
It's come from supernovae.
elsewhere.
The end.
Is that the supernova come from
Nope.
neutron stars colliding?
So
Why have I got that in my head that the gold come from two neutron stars colliding?
I don't know why you have that in your head.
That's why what I get for trying to learn stuff off TikTok, innit?
I thought supernovas were made of champagne. That's the extent of my knowledge. Right, we're going to talk about, we're going to have a break, we're going to record Pigoted Extra, we're going to talk about the origins of the universe.
Yeah.
If you want to get involved in Pigoted Extra and listen to it, you can. All you need to do is be a Patreon, and you can do that by heading over to patreon.com/pigoted. And now you pay £4 a month, £1 a week, and for that you get access to all the extra content, 2 extra episodes a week, plus access to Discord servers, discounts on merchandise. The way I like to think about it is this. Would you notice if we spent a week not uploading an episode of Pigoted? And if the answer to that is yes, would you notice if £1 left your bank account? And if the answer to that is no, then obviously it's a no-brainer. Sign up to the Patreon, and so you can help support the podcast, and you will get a literal shitload of content for just £1 a week. Before we go, is there anything that you want to plug, Dean?
Go follow me on social media, Dean Coughlin _ and go check out the Mild High Club. It's a little podcast I've got going on.
And Ben?
Go look up Jocelyn Bell Burnell. She's still alive.
Hey,
Is she?
Try and get her on. Reckon she'd come on?
Hi, Jocelyn. In a previous episode, we referred to you as Jocelyn Foreskin Burnell. What do you?
Will you come talk
like
about the giant gob stuff?
Yeah, would you like to talk
lightsabers
about
out of it?
Stop it, that you and Warwick Davis?
Yeah, she'd be like, what is this? What are you on about here? Straight in the bin.
Oh, fuck. Thank you for coming on, man. We'll see you next week. Bye.
Bye.
This episode of Pigoted is sponsored by Taylor's Toys. Taylor's Toys are a sex toy company. They specialise in doing high-quality sex toys that won't fall apart after 1 or 2 uses. Head over to taylorstoys.co.uk, check out the amazing range that they've got on offer, and if you use the discount code PIGOTED at checkout, you get yourself 10% off on all products. Taylor's Toys. Spice things up in the bedroom. Thank me later.